Let's look at another example of finding a derivative. And so in this example we have y equals the sine of x plus the cosine of x over the cosine of x. And we want to find dy dx. So remember, dy dx is another way of saying we want to find the derivative of y with respect to x. And so we're going to do this two ways. So method one, we're going to use the quotient rule. Okay, so we have y equals the sine of x plus the cosine of x all over the cosine of x. Okay, so the derivative of y with respect to x, y prime. Okay, so the quotient rule, we have our denominator or the bottom, which is the cosine, and we have our numerator or the top, which is sine of x plus cosine of x. So you have to, again, somehow remember the quotient rule. But the way I say it is the derivative of a quotient is the bottom, which is the cosine of x, times the derivative of the top. So the derivative of the sine is the cosine of x. The derivative of the cosine is a negative sine of x. Then we subtract from that the top, which is the sine of x plus the cosine of x. And then we take the derivative of the bottom, which is a negative sine of x. And this is all over the bottom squared, cosine of x squared. Okay, so there's our derivative. We have the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Okay, now in this example we do need to simplify things. So let's go ahead and do that. So y prime is going to be, okay, cosine times cosine is the cosine squared of x. Cosine times a negative sine is a negative cosine of x sine of x. Okay, over here these two negatives cancel out, so then we're going to add sine of x times sine of x is the sine squared of x. Sine of x times cosine of x is plus cosine of x sine of x. And this is all over the cosine squared of x. Okay, so a negative cosine of x sine of x and a positive cosine of x sine of x, they cancel out. And so y prime equals the cosine squared of x plus the sine squared of x all over the cosine squared of x. Alright, so, well, cosine squared plus sine squared is 1. That's one of our Pythagorean identities. So we end up with 1 over the cosine squared of x. And so y prime ends up being, well, 1 over cosine secant, so we get the secant squared of x. And there is our answer. Okay, now I said there was a second method we could do to figure out this derivative, and method number 2 is to rewrite. So we have y equals the sine of x plus the cosine of x all over the cosine of x. So we can rewrite this to be, so I'm going to split this into two fractions. So we have the sine of x over the cosine of x plus the cosine of x over the cosine of x. So y is going to be, let's see here, the sine of x over the cosine of x plus 1. Okay, so now we can take the derivative. Y prime. And we still have a quotient in the first one, but let's go ahead and look at that. We have the bottom, the cosine of x, times the derivative of the top. The derivative sign is cosine of x, minus the top, which is the sine of x, times the derivative of the bottom, which is just a negative sine of x, all over the bottom squared, cosine squared of x. And then the derivative of 1 is just 0. Okay, so our derivative, cosine times cosine, is the cosine squared of x. Sine times a negative sine, well, there's a negative here, so that becomes plus the sine squared of x, all over the cosine squared of x. Okay. Now cosine squared plus sine squared is 1, so we get 1 over the cosine squared of x, and that ends up being y prime equals the secant squared of x. So again, I wanted to show you that sometimes there are two methods. We could have used the quotient rule, we could have rewritten. We ended up using the quotient rule again, but I don't know, maybe this one was a little bit easier. You know, I'm just trying to get you guys to start understanding that sometimes you have to look at how maybe you can solve these problems or get these derivatives, and sometimes there are simpler ways and sometimes there's not. So here's another example of using the quotient rule. Again, using the quotient rule, a lot of it is just remembering what it is and specifically what order things need to be in.